Day 3, Algebra. And today is going to be short on Algebra. We're looking at the last section which we are supposed to deal with, which is just nature of roots. Now, the first thing I'm going to quickly explain is what roots are. All right. Roots are the solutions. All right. Roots are the solutions of two equations. Roots are the equation. So basically, it's an extension of simultaneous. Roots are the solutions of two or more equations. Let me put or more there. Two or more. Equations. So please take note. So this is going to come in very handy. Solutions of two or more equations. I'm going to extend it from what you know in grade 11. I'm going to go a bit deep here. All right. Roots are the solutions of two or more equations. All right. Graphically, we refer to the point of intersection. I'm already into functions now, and I'm sure you remember what point of intersections are. The point where two or more graphs meet. All right. So where they meet is what we call roots of the solution. Graphically, we refer to the point of intersection. All right. Now, basically, there are two types of roots, and I'm going to break them down. Let me go to the next page to break down. So we have types. Let's get a fresh page. All right, types of roots. Roots are basically segmented into two. All right. We have real and unreal. Those are the two that we have. Real roots and unreal roots. What do I mean when I say real roots? We are going to say that the solutions exist. Remember what we said roots are? Solutions of two or more graphs. For unreal, we are going to say solutions does not exist. And another word that we would use for unreal is non-real roots. So you could see the word unreal or non-real means the same. So take note. So when roots are real, the solutions exist. They are tangible. All right. But when roots are unreal, the solutions do not exist. Okay. Now, having said that, our main focus would be to work with what we call discriminants. Okay. But I'm going to divide my real root first, all right, into real. So our roots could be real and equal, all right. Let me do a different division. Let me do something else for space. Okay. So roots can be real and equal. All right. Can be real and unequal. And then can be real and rational. Roots can be real and equal, real and unequal, real and rational. What are the conditions? Let's move. The conditions are this. Here, my discriminant, we will look at that, will be equal to 0. My discriminant will be greater than 0. And my discriminant here would be a perfect square. When you say something is a perfect square, our discriminant would come out like that, with a square on top. So real roots can be real or unreal. For it to be real, we have equal roots, unequal roots, and rational. Conditions, we basically work with this discriminant. I'm going to explain the discriminant later on, just in a moment. When it is equal to 0, it is real. When it is unreal, it is greater than, when it is unequal, it is greater than 0. Rational, then the discriminant is a perfect square. When it is unreal, our discriminant is simply less than 0. Now, I'm going to quickly write something here. So when we say our roots are real, I want to combine this. We can simply say discriminant is greater than or equal to 0. Please take note. When I say real, greater than or equal to, but I can then be specific by saying real and equal, real and unequal. Do you see I'm splitting that? Both of them are real, while rational is a perfect square. You cannot forget these conditions. And when it is less than 0, we say it is unreal. What is our discriminant in itself? Discriminant is b squared minus 4ac. And I hope you remember where you get that from your quadratic. Remember, x equals to minus b plus or minus square root of what? B squared minus 4ac over 2a. So our aim or our focus is right inside that square root. That means an examiner can write something like this. Don't be shocked and don't behave as if you've not seen before. All right, I hope you see that. So don't be shocked. Our discriminant, all right, discriminant. This is what determines the type of roots we are going to get. Let me quickly run to functions just for a moment. I don't want to stay long in it. When I have equal roots, or let me do that on the next page. No, we can squeeze it in here so that when you take a screenshot, you have just one screenshot. All right. Now, when I say roots are equal, look at what your graph would look like. Your graph will have one point of intersection. It turns right there. Please take note. It's just one point. It turns right on the axis. That's what we mean by roots are equal. All right. So that is referred to as equal roots. Equal roots. When they are unequal, this is what we are used to, and some of us don't really understand what it is. Can you see there? Let me change the color there. These roots are not equal. x1 is not equal to x2. If I were to do that, so x1 is not equal to x2. Here, x1 is the same as x2, which is basically equal to x. I hope you see the difference. All right. And when we come to unreal, the graphs don't touch each other. Now, I'm hoping somebody would ask a question because, guys, I wanted to understand this right from the beginning. I want you to understand this right from the beginning. Permit me to go back just a little on the first page. Roots are the solutions of two or more equations. All right. And graphically, so please check this. I want to quickly show you something here. I want you to see this. If I draw this, there are three equations here. This is the first one, equation 1. Are you aware that that is another equation, equation 2? Hence, we say it is the point of intersection between two. Let's make this green. Hence, we say these are the roots, the point of intersection between two graphs. Guys, understand this, which means if I have a graph like this, this can also be referred to as roots, because we can use nature of roots to solve them. Please take note. We can use nature. At this point, we're talking about, you see, these 2 points of intersection, we're talking about equal roots here. I hope it makes sense. We're going to get questions where you need to solve things like this. All right? So please understand what roots are. Roots are not just on the x-axis. It is the point of intersection. It's another way of solving a simultaneous question. So we need to open ourselves to a lot of applications. All right. So roots are solutions, and there are two types of root, real and unreal. Under real, we talk about 3, equal, unequal, rational. All right. Equal to 0, greater than 0, being a perfect square. I hope we get examples today. And it's unreal. Our discriminant is less than 0. What is your discriminant? B squared minus 4AC. All right. B squared minus 4AC. Awesome. You would see graphically what the rational would look like as we go on. All right. But it will be more of on the equal side as well. Okay, guys. Let's start. If you understand what I've said so far, all of these questions are very straightforward, so I'm going to run because I'm actually still in time from the next topic. Given x minus 2 equals to minus 4 over x minus 2 minus 2. If y equals to x minus 2, interesting. Show that the given equation can be written as that. Oh, if y equals to that, I think that's very straightforward. Y is x minus 2, so I can simply say that anywhere I see x minus 2, I'm going to write y. Minus 4 over y. I hope everybody's okay with that. And you know how we get rid of the denominator. We multiply by the denominator. So y times y, please get used to that. To get rid of the denominator, multiply by the LCD. Y times y is y squared. The y here, let me do this. I'm only going to do this one time, but you can see this. This is what I'm saying. Multiply every term by the denominator, the LCD. So what do you have? Y squared, that will divide, minus 4, and that will give us minus 4y. Let's move everything over to get a zero factor rule. Y squared plus 4y minus 4 equals to 0. We're done with 1.3.1. That's maths. Easy. Just simplification. Hence, now please take note. When the examiner says hence, learn this right now in case you didn't know, and let it stick to you, whatever you know. Hence means start from the previous answer. When they say hence, it's a continuation, continue from whatever you got. Hence, So that means we're going to start from y squared plus 4y plus 4 equals to 0. Show that what? They said show. Please take note. Show that the equation has what? Real and equal roots. Wait. Do you guys remember the condition for real and equal? Do we remember? Let me see. It's positive 4. Oh, thank you. Positive 4. Yes. Thank you. Show that the equation, do you remember the condition for real and equal? Don't forget, for it to be real and equal, do you remember? Our discriminant must be equal to 0. Show that the equation has real and equal roots. Okay. So if my discriminant is, thank you, roots equal to 0. Thank you, Monica. So we are required to show that this is equal to, please take note of the expression. If my discriminant is equal to 0, then, so I am not going to equate it to 0. I must show that it is equal to 0. I hope it makes sense. So let's find our discriminant. Our discriminant is what? B squared minus 4AC. Do you guys remember where to get your A, B, and C from? That's your A, that's your B, and your C. So my A is 1. Remember, there's a 1 there. My B is 4, and my C is also 4. Please, the signs are important. All right, but in this case, it's positive. So check this. Do you see I'm not saying 0? I'm not bringing in the 0. What is my B? 4 squared minus 4. What is my A? 1. What is my C? My C is 4. Oh, what do we have? 16 minus 16. Oh, so since that is equal to 0, it means that what? The roots, do you see what I did? The roots are real and equal. So you don't start by saying discriminant is equal to 0. You just need to remember. We normally say required to prove that discriminant is equal to 0. You are required to prove that the discriminant is equal to 0. So you solve it first. Okay. Guys, quickly give me your okays. Let's move. Let's move, but get me your okays first. Are we all good? Beautiful. Look at this one. The root of a quadratic equations are given as follows. Determine the values of P. I wanted to see how I'm going to approach this one now. Determine the values of P for which the equations have non-real. Take note, non-real. What's the condition? Non-real, unreal. Our discriminant must be less than 0. Now, they are not asking us to show. They are asking us to find the values of P. So we need to come here and start by saying discriminant is less than 0. And in this case, you don't need to put up your B squared minus 4AC. No. Why not? Why not? That is my discriminant. Remember we talked about that? That whole thing there is my discriminant. So what do? We just bring that in. P, 6 minus P minus 9 less than 0. And I'm glad we did inequalities. This is where it's going to come in handy. We expand, all right? 6P minus P squared, all right? What do we have? Minus 9 less than 0. Minus P squared. I'm just rearranging. All right, check this. Before you start solving, guys, make sure that your A here is positive. So what do? I'm going to multiply through by negative. It's always easy. So P squared minus 6P plus 9. Now, when I do that, remember the rules. Lesson 1. I am changing or multiply by negative. It means this must be greater than 0. Now, this is where I am solving from. I remember someone asked that question. This is where I am solving from. Do you remember the rule again? If it is greater than 0, what should my answer be? My answer should be greater than or less than. But the question is, what is our critical value? What are the critical values here? We expand this. It's p minus 3. JJ, do you see that this is going to be somewhere rational? Because it's p minus 3 squared. Okay, but check this. Greater than 0. I want to teach you something that I forgot when I was dealing with inequalities, but we'll get to see it here. Now check this. I only have one CV. My CV is 3. Please take note. I forgot to mention this when I did inequalities. When you have one CV, what do? How do you represent your answer? Look, it is still correct to say that P would be greater than 3 and P would be less than 3. Because we said greater than 0, you have greater and less than the small critical value and the big critical value. But guys, we only have one critical value. So what does this really mean? It means P is an element of real numbers, but P cannot be equal to 3. That's how you write your answer now. We are saying P is greater than 3, all numbers greater than 3. P is all numbers less than 3, which means the only number P cannot be is 3. I don't know if that makes sense. P can be any number except 3. And I want to show you what this means in terms of nature of roots. Before I show you what this means in terms of nature of roots, please, is there anybody who is lost here? Quickly. We have P minus 3 greater than 0. It means P is greater than 3, P is less than 3. But our answer can be well written as P is an element of real numbers and P is not equal to 3. Is there anyone who is lost? So, Mela, where are you lost? Quickly. So, Mela, you need to quickly respond. All right, I'm going to continue until you respond. All right, guys. So we are saying determine the values of P for which this thing will have what? Non-real roots. The values of P, all right, would be any value apart from 3. What happens when we substitute? Guys, please, can you look at that equation, x equals to 5 plus or minus, all of those. Please substitute P as 3 for me and tell me what you get. In that equation, substitute P as 3 and tell me what you get. Where we find the p, we factorize this. So Mila, factorize. P squared minus 6p plus 9. It's a quadratic expression. Find the factors of 9, 3 and 3. If you add them, it will give you 6. So negative 3 will give us negative 6. Factorization, day 1. It's a trinomial. We're solving trinomial. P squared minus 6p plus 9. Two numbers that when you multiply would give you 9. When you add them would give you negative 3. So it's p minus 3, p minus 3. All right. When you substitute 3, what do you have? Guys, why are you getting different answers? Somebody says 5/2. In the whole, what is x? All right. All right, 5 of Keith, you're doing something wrong. You cannot get that. Substitute. I just wanted you to see something here because I want to explain something to you. Substitute p as 3. So what do we have? We have 5 plus, we have 5 plus the square root of 3 into bracket 6 minus 3, all right, minus 9 over 2. All right, you have 5/2. That's what I wanted. I wanted you to see something from here. Now, I am substituting my p as 3. Let us choose a different. We said p should not be equal to. Do you see that these roots are real? It's 5/2. The answer exists. But the question says that what are the values of p such that this root will be non-real? We said our p should be either greater than 3 or less than 3. So I'm going to choose just a random number. Instead of 3, a number greater than 3 could be 5. I wanted to see the meaning of what we've done. Error. That is no solution. As long as p is not equal to 3, I hope you understand what nature of roots are. Examiner says, determine the values of p for which the equation will have non-real roots. We said our answer should be greater than 3 or less than 3. When we used 3, we got a real root, but we want it to be non-real. So p has to be greater than 3 or p has to be less than 3. And we chose 5. Let me choose a number less than 3. Let's choose 1. Non-real roots. Do you see? Error. So every time you do something like this and you get an error, it means it has no answer, no real root. So this x value will have no real root for all values of p except 3. I hope you understand the implication of what we did. I hope you understand. If the examiner had said real root, then it would have been p greater than or equal to 3. But we're dealing with non-real roots. Guys, I hope you understand the roots now. Because we have no answer, no solution, it means there are no roots. The roots are non-real. The roots do not exist. Right? Four or 1. But I'm seeing -1 and -1. -1 and -4. Which one is correct? Monica says x equals to 4. Your signs are very important. All right, for this thing to be real, what do we know? Our discriminant must be greater than or equal to 0. All right, for that to be real. And basically, look, what this examiner is saying now in this case, let me even explain this, is that for this thing to be real, everything under, check this, please understand what the examiner is asking as well. Everything here should be what? Positive. Okay? It should either be 0 or positive. The whole thing, remember what we said, our discriminant is what is under the square root. So basically, examiner is saying, solve this equation. What are your factors? No, it should be 4 and 1. X minus 4, x minus 1. Oh, what are our CV? Our CV are 1 and 4, right? So basically what I was saying, x should be greater than or equal to 4, x should be less than or equal to 1. Our CVs are 1 and 4. So I don't know, you guys are getting, some of you are getting the negatives from. Where is the negative minus, where is the negative 1 and negative coming? All right, guys, please let's take note. Everything under the square root should be greater than or equal to 0 for it to be real. Basically, it's an inequality question. I hope this makes sense and you're correcting yourselves. I only had a few people responding, which is not nice. I need everyone to respond because it makes me then know that we are here and we are following. Guys, are we okay with this quickly? Let's see if we can spend 5 minutes more on this. I need all the responses I can get. That's how I would know. Remember, it's a virtual class. That's how I would know if you are on board or if you are lost. We need to keep the communication going. And when I ask a question, please put in your answers as well. It helps a lot. All right, I'm glad we're okay. Let's see. I'm not going to do all of this though. Let's say this one would be non-real. This is similar to what we did earlier on. Just going to explain what you're supposed to do there, and then you can try it later. Right. Determine the values of m for which the roots would be unreal. Again, the examiner is using unreal. Your focus is always on the under the square root. That's where your focus is. So everything under the square root there should be what? Less than 0. I'm sure you can take a screenshot in case we delay in sending the PDF, and you can solve this later. And we can share, whatever group you are in, we can share your answers. Let's call this question 1, so that everybody then knows what we are referring to. So this is question 1. You can share, remember it's the last day of maths today. For now, question 1. So share your answers on the group. Okay, we'll give a time frame. Question number 2, similar. For which values of k will the roots be equal? You know what it is when we say roots are equal. You mustn't forget the conditions. The discriminant should be equal to 0. I've already done this by telling you all of that. And I hope you've taken screenshots. Question 3, which is the last one. I'll do this one. Show that the root 3x squared plus that are what? Real and rational for all values of k. Real and rational. Let's see. Since we're talking about nature of roots, we need our b squared minus 4ac. So 3x squared plus k plus 2x. I'm going to use the zero factor rule. minus 1 plus k. I hope that makes sense. 0 factorial. Now check this. Ax squared plus bx plus c. I want to do this for clarity. What is my a? What is my a? My a is 3. I hope it makes sense. What is my b? The coefficient of x. It's bx. So b is k plus 2. Take note. B is the coefficient of x. And what is my c? It is the whole constant there. Minus 1 plus k. If you want to write it nicely, k minus 1. Please, I hope that is well understood. Your a, b, and c. Now, for that to be real and rational, what do we know? Real and rational. Rational, real. We know that discriminant, all right, must not only be greater than 0, but it must also be a perfect what? Square. Okay. Now, b squared minus 4ac. Let's go solve that. What's our discriminant? Our b is k plus 2 all squared minus 4, 3. What is our c? K minus 1. Okay. Let's simplify that. We expand that. By now you should know how to expand. K squared plus 4k plus 4. All right. Minus. To make this easy, I'm going to say 12 there into bracket k minus 1. Just to make it easy, I could have jumped that step, but we don't want to make things complex. K squared plus 4k plus 4. All right, what are we going to have? Minus 12k plus 1. I hope it's making, no, minus, plus 12 rather. I hope it's making sense. We just expand. All right, let's simplify. K squared plus 4k minus 12k, like terms, right? Plus 4 plus 12. What do we have? K squared. What is 4 minus 12? Minus 8. 4 plus 12 plus what? 16. Can we factorize that now? What would this be? K minus 4, k minus 4. Oh, check this. There. Do you see I've got a squared? Rational. And definitely if it's a squared, it is greater or equal to what? 0. So since the discriminant is a perfect square, all right, the roots are real and rational for all values of k. Please talk to me. Do you understand? This is the last question on nature of roots. You can find more in past papers, but are you okay? I just wanted us to see the A, B, C in this one and to see how to walk around the rational part. You see that my discriminant gave me a square. So don't forget what you are required to show, the conditions. Rational means it must be a perfect square. All right, I'm getting your okays. All right, I'll go back, Sumila. All right, we're good. Lovely. I hope you've taken a screenshot of this. I'm going back. Sumila asked me to go back to question 2, the homework, so that he can take a screenshot. So I'm moving. There we go. And guys, I am done with algebra. The next hour right now, I am going to deal with number patterns. Okay, I'm going to move a bit fast in number patterns because I want to cover one of the concepts. But I hope everyone is okay. All right, good. This has been algebra all the way. All right, so we are done with algebra part 3, which was just simply focusing on nature of roots. All right.